All right, for 5.4 fundamental theorem of calculus, part B. So net area versus total area. Net area refers to the positive area combined with the negative area. This is what we've been doing. Whenever we integrate, the integral is equivalent to finding the areas in between the graph and the x-axis and putting those together. Now, sometimes the area was negative, and so obviously a negative number, a positive number, some of that area would get canceled out. But that is to integrate, um, that is your answer. Now, in some instances, you'll be asked to find the total area. And the total area refers to the area bounded by the curve and the x-axis, but they always want to have it be positive. Okay, so I'm just going to make up an example here real quick. Okay, so here I have some area, and then here I have some more area, right? And let's say that this up here is 5, and then this down here is -8. Now, if you were asked to find the net area, then your answer would be -3. But, right, because 5 plus -8 is -3. If you were asked to find the total area, they actually want you to pretend that this bottom part of the graph was on top. Kind of like this. And then all of a sudden, this area is a +8. And your total area would be the 5 plus the 8, which is 13. Big difference, right? Okay, so example 1. Evaluate the integral. So here I have a graph of my function 4 minus x squared. And when I'm asking you to evaluate the integral, what I'm actually asking you to do is to find the antiderivative, right? Or another way is to look at it is to find this area and this area and add them together. And yes, the area underneath the x-axis is going to be negative, so it'll cancel out some of the top area. All right, so real quick, I'm going to integrate this. So I get 4x minus x, let's see, squared becomes cubed, and then I would divide by my new exponent. And I'm evaluating this from, let's see, let's look at my limits. It says 0 to 3. Okay, so plug in the 3. So 4 times 3 minus 3 cubed over 3. And then minus, plug in the 0. So I get 0 minus 0, which is 0. So 12 minus 27 divided by 3 minus 0. So 3. The answer is 3. Okay. Now this, folks, this is net area. And you're just evaluating an integral. That is the idea of net area. All right. B. It says find the area of the region between the curve y equals 4x minus, or y equals 4 minus x squared and the x-axis on the interval from 0 to 3. Now B, it's asking me to find the area of the region between the curve. When they word it this way, they want you to do the total area. So for total area, so look at my old graph, look at my new graph. Basically, what they're asking you to do is they're asking you to find the area from, let's see, 0 to all the way to 3, right? So this is the area between the graph, the curve, and the x-axis, right? Right here. And then this down here is also the area between the curve and the x-axis. It's just that they want you to make pretend that that area down there is actually on top, like so. So you're just gonna pretend that it's not negative any longer. Let's see here. That it's not negative any longer and that it's positive. That's basically what they're asking you to do. They're asking you to find that area there by finding total area. You can just look at it as whatever's negative, you need to make positive. So that way, I'm still going to do this. This doesn't change. The only difference is that my answer needs to be positive. Okay? So when we mimic whatever it is that we did on top, I need to realize that, this graph does actually become negative at some point, and I need to figure out where that location is. Okay, so the way to integrate this properly and to find the total area, I'm going to need two integrals. And I'm going to add them or subtract them, depending on how you want to look at it. And I'll explain in a second. Okay, so first off, I'm going to go back to the original graph that I had. All right, so here you can see that the graph changes from being above to below at x equals 2. So from being positive to negative. We can figure out where that location is by taking this, setting it equal to 0, and figuring out what x is. So subtract 4. So I have x squared equals positive 4, so x equals plus or minus 2. Now, negative 2 is not in this interval, so positive 2 is. So that means that now I have new partitions. My limits are different. It is now from 0 to 2 and from 2 to 3. So 4 minus x squared dx. And then over here is still going to be 4 minus x squared dx. But I have partitioned this into two areas. The blue area is being depicted by this first integral. And the red area, so this is the blue, and then this is the red. Now, you can either remember that you have to make whatever answer you get here positive, or you could, instead of adding these areas, you could subtract them, because your answer here is going to be negative. So if you subtract the negative, it becomes addition. Okay? All right. So let's see. Do the antiderivative, which we did on part A. And you're going to plug in the 2. So that's 4 times 2 minus 2 cubed, which is 8 over 3, minus, and then plug in the 0, 4 times 0 minus 0 cubed over 3, so 0. Right, that's the first one here. Minus. And now the negative one. So I get 4 times 3 minus, let's see, 3 cubed is 27. 27 divided by 3 is 9. And this is just the first part. Subtract, plug in the 3. So 4 times 3. Oh, look at that. 4 times 2 is what I meant. Sorry. 4 times 2 minus, and then, okay, so 2 cubed is 8. 8 divided by 3. And that's the second part. And if you notice, right, because you use your eyeballs and you're not blind, hopefully you notice that this part is actually the same as this beginning part, because the limits, the numbers I'm using are the same, and they should be. Okay? All right, let me move down a little here. All right, so do a little bit of math. Okay, so I did some math there. A little bit of more math. All right, and then I finished it off. And I got 23 over 3. Very different from our answer from part A, which was 3. 23 over 3 is roughly 7.66666, right? So Um, it's a way bigger area. Okay, C. Use the graphing calculator to find the area of the region between the curve. So now we're gonna do the calculator. Now, for the calculator, you're gonna have to enter it like this. um, you don't have to partition. You see here how we partitioned? We went from 0 to 2, and then from 2 to 3. I don't have to partition for when I do it on the calculator. On the calculator, you're simply going to do math number 9. This is for the TI-83s, right? Math number 9, which is indefinite, which is integral. The little symbol will come out, and then you'll put 0 to 3. And then I need you to go into, I believe it's the math, and then over to number, and select ABS, which is absolute value. And these will come out. Absolute value bars, right? And then 4 minus x squared, and then don't forget the dx, and then hit enter, and you'll get your answer. So we're going to go ahead and try it. All right, so as mentioned, so math, you go number 9, that's for integrals, and then from 0, and then, uh-oh, is that a double 0? Oh, is this thing having a cow? What's happening here? Okay, so delete. So 1, 0. All right. 2, 3. And then go to math, and then over to number. So you're going to go to the right. And the first one is ABS, which is absolute value. So you're going to hit number 1. And then the absolute value bars come out. And then you put in 4 minus x squared. And then the dx. And hit enter. And any moment now, it's 45.65. Which is wrong because somehow there's another square there. Okay, let me try that again. I'm sorry. Alright, so I plugged that in again without an extra square. Hit enter. Any day now, and we get 7.66666. Okay? So that's that. So for the calculator, you need the absolute value. Alright, example 2. The graph of a piecewise linear function f for -1 to 4 is shown on the right. Find, okay, so for A, I'm going to find, or I have to evaluate the integral from -1 to 2. Now I don't have a function, and that's okay because I have a graph. So from -1 to 2, so really I'm looking for this area. Now, this is where you get creative. This area is in the shape of a trapezoid. So if I want to find that area, I am going to find the area of a trapezoid. What if you don't remember the formula for area of a trapezoid? And honestly, it's not that hard. Let's see. 1/2 times the height times base 1 plus base 2. Okay, that's the area of a trapezoid. And, okay, so like I said, what if you don't remember? Well, then this trapezoid is actually, here's a triangle, and here's another triangle, and then in the middle we have a rectangle. And you're more than welcome to find the area of all 3 of these objects. I'm going to do the trapezoid because you have to learn how to do trapezoid area anyway. So 1/2. Now, how tall is this baby? Well, let's see. It is 2 units tall. And then base 1 plus base 2. So here's a base. It is 1 unit long. And here is another base. It is 3 units long. And there we go. So 1/2 times 2, that's 1. And then 1 plus 3, that's 4. All right, B, from 2 to 4. So this time we're looking for the area from 2 to 4. And that would be from here to here. So it would be all of this, which is another trapezoid. So 1/2 times the height. Let's see how tall is this baby. It's 1 unit tall. Times the base 1 plus base 2. So here's a base. It is 2 units long. And here's another base. It is only 1 unit long. So half of 1 is a half, and 2 plus 1 is 3. So 1/2 times 3, so 1.5. Right, part C. This time I'm looking for the area from -1 to 4. From negative 1 to 4, that's the whole thing, all the way across here. Okay, so for part C, I'm looking for all of the area. Now I want you to recall that the area up here was 4, and the area down here was 1.5. But it was actually negative 1.5, right? So negative 1.5. And so we have 4 plus negative 1.5, so 2.5. And there you go. All right, part D. So now for part D, they want the total area between the graph of f and the x-axis. So this time around, what we're really doing is from 4 to negative 1, we're doing this, which means it's going to be 4 plus negative 1.5, but in an absolute value, right? Or, like I said, you can do 4 minus negative 1.5, whatever, it doesn't matter. So that I'm going to have 5.5. Okay, hope you see the difference there. All right, example 3. The functions f and g are given by f of x equals the square root of x and g of x equals 6 minus x. Let R be the region bounded by the x-axis and the graphs of f and g as shown in the figure below. And I did forget to actually put what I wanted you to do. I want you to find the area which is labeled R. Okay, so very quickly, find R. Okay, so here we have two equations. We have two graphs joined together, and they meet here at this point, 4, 2, and they make this area with the x-axis. So kind of sort of like example 1, where we had to partition because of the negative and the positive area. Here we're going to have to divide this up into two integrals. One integral is going to be for f of x, and the other integral is going to be for g of x, because they are two different equations. And the point where they're going to be, or we're going to be cutting this, is where they meet. See right here? That'll be my partition, because f of x takes care of all this area. The graph of f of x is all of this area, up to 4. After 4, the equation I'm going to need to find the area is the equation of g of x. Okay, that equation will help me find this area. So, the way you would write this is this. It'd be like, okay, from 0 to 4, right, I'm going to find the area of f of x, and f of x is the square root of x. And then whatever area I get from there, I'm going to add it to the area I get when I integrate g of x. And that's going to be from 4 to 6. Okay? It's really important that we pay attention to our limits. Okay, from 0 to 4, and then from 4 to 6. Okay, and then g of x was 6 minus x, dx. And then you can do this, you can integrate, and then add them, and that'll take care of the area. Okay, you're just partitioning this into two pieces. Now, side note, g of x. You actually don't have to integrate g of x. If you look at this triangular area, it is a triangle. And the area of a triangle is 1/2 base times height. So 1/2, the base of the triangle, so from 4 to 6, that's 2 units. And the height of the triangle, it goes up to 2, so that's also 2 units. So 2 times 2 is 4, and half of 4 is 2. So ideally, this integral should equal 2. Ideally, and you could do it the long way, if you please. You don't have to, well, not the long way. I shouldn't call it the long way. Alright, so I'm going to go ahead and integrate the square root of x, which, let me remind you, is actually x to the 1/2 power. So when I integrate that, it becomes x to the 3/2 power, but then I'm going to divide by 3/2, which is the same as multiplying by 2/3. And then I'm evaluating this from 0 to 4. And then g of x we decided was just 2. Okay, so plug in the 4. So let's see, 3 halves to the power of 3 halves, which is basically saying square root and then cube it. Okay, so that's not so bad. So let's see, 4, and then I'm going to, you know what, let me not write it like that. 3 halves means I'm going to square root and cube it. So square root of 4, and whatever that is, I'm going to cube. That makes it friendlier. And then minus, and then plug in the 0, and oh, I get 0. And then plus 2. So let's see, 2/3 times 2 cubed, which is 8, plus 2. 2 times 8 is 16, 16 over 3 plus 2. 16 over 3 plus 2, so that's 16 over 3 plus 6 over 3, which is 22 over 3. And there's my answer. Alright, so example 4, here I have a piecewise function. Kind of like example 2, only this time I actually have an equation. And I need to find the integral, or evaluate the integral from -4 to 4. Now, this piecewise function is telling me that all the way until it becomes 0, this graph is x minus 2. And then at 0, it's actually, because this is saying x is greater than 0, so this is positive. The positive numbers, positive 1, positive 2, positive 3. After 0, the graph actually looks like x squared. So in order to find this integral, I am actually going to have to do 2 integrals. One is going to be from -4, and here's where I got the -4 from, all the way up to 0, right? And this is where I got the 0 from. And then the other one is going to be from 0 to +4. And then what goes in here is going to get added, right, to this. Now the equations. From -4 to 0, I need to figure out what part of this piecewise function is actually the part that belongs in this interval here, from -4 to 0. So for x minus 2, x is smaller than 0. And this would be -4 is smaller than 0. So here would go x minus 2. And then for the other one would be the x squared. And now I have 2 integrals, but they will cover this area that I need from -4 all the way to +4. And that's how you're going to do piecewise functions. So integrate, and I get x squared divided by 2 minus 2x. And you're going to evaluate that from 0 to -4, or -4 to 0, sorry. And then you're going to add that, and so x squared is x cubed divided by 3, and you're going to evaluate that from 0 to 4. Okay, so plug in 0, so we get 0, and then minus, and plug in the -4. -4 squared is 16 divided by 2, so that's 8 minus 2 times -4 is -8, but that becomes a positive, so there we go. And then plus, okay, we're going to plug in the 4, so 4 cubed divided by 3, so that's, what, 64 divided by 3? Oh, I was going to write 3. 64 divided by 3. And then plug in the 0, so that's -0, so I'm not even going to write that. So here I have -16 plus 64 over 3. So let me have a common denominator, so negative 48, is that right? I'm having this big brain fart. So negative 48 over 3 plus 64 over 3. Do a little bit of math. 16 over 3 is my answer. All right, example 5. Same idea. It's just a piecewise function. And actually, I want to go ahead and let you guys do this one on your own. Please try. So now would be a good time to pause it. So you want to start off by figuring out your limits. So I need to evaluate from 0 to 5. And according to my piecewise function, at 3 is where they split up. So I'm going to do the first half from 0 to 3, and then the other half from 3 to 5. And then you have to figure out which one goes where. So from 0 to 3, the graph, or the equation I'm going to use is this one. Because here, x is greater than, oh no, Oopsie, I'm confused on the other one. I'm going to use this one because here my x is less than 3 and 0 to 3 constitutes that's less than 3. So x minus 1. And then, so then that just leaves the other. 3x squared minus 8x plus 5. So then you would integrate. So there's the integral of both. And then now we're going to evaluate by plugging in the 3, the 0, the 5, and then the 3 again. Here's the next step. Here's the next step. And the next. And there's my answer. Example 6. Okay, so sometimes they'll throw this at you. You have an integral, but it's incomplete. And you have to figure out what that k could possibly be in order for the integral to equal 16. So you're going to just treat it like normal. Keep in mind that that is a constant. It is a number. Okay? That k represents a constant. So it's like if it were a 3 or a 4. When you integrate that, you should tack on an x to it. So you would do the same here. So x to the 7th power becomes to the 8th divided by 8. And then plus, and then k becomes kx. And then we evaluate this from negative 2 to 2, keeping in mind that this should equal 16. Okay? Should equal 16. So plug in the 2, and you get 2 to the 8th over 8 plus 2k minus, now plug in the negative 2. So negative 2 to the 8th, which is the same as 2 to the 8th, over 8th plus 2k. And this should still equal 16. That's the goal anyway, to figure out what number I can plug in here and get 16. Okay, so 2 over 8 divided by 8 is 32 plus 2k minus, let's see, negative 2 to the 8 divided by 8 is still 32 plus 2k equals 16. And here's where people are going to mess up. This negative belongs to both of these. So 32 plus 2k minus 32 minus 2k equals 16. I knew that looked funny. And of course, I messed up. Negative 2. Oh, look at that. Negative 2, Narita. Negative and negative make positive. And you looked funny. Okay, so anyway. So 32 plus 2k minus 32 plus 2k. So this 32 and that 32, since one's positive, one's negative, they cancel out. And now what I have is 4 k's total, right? I really meant that to be in red. So 4 k's total equals 16. So 4 times what number gets me 16? Or divide both sides by 4. So k should be 4. And that's that. Okay, so example 7. So here this is all very abstract. I have a's and b's in here, no numbers. So they were telling me that the integral from a to b of f of x dx equals a plus 3b. So then they're telling me that the integral from a to b of f of x plus 6 dx equals what? Okay, so basically you're splitting this up into 2. You have from a to b of f of x dx plus from a to b of 6 dx. And the idea is that this is the same as this. So we know what it equals. It equals a plus 3b. But then I get to add that to whatever the integral from a to b of 6 is. And so if I integrate 6, I get 6x. And then I just have to evaluate from a to b. Okay, so moving along. So a plus 3b plus, okay, plug in the b, so it's 6b. And then minus, and plug in the a. So a plus 3b plus 6b minus 6a. Simplify, as I'm sure we all know how to do. So let's see, I have 1a and negative 6a's. That's a total of negative 5a's. And then I have 3b's and 6b's. That's a total of 9b's. I'm just going to write it like this so the negative's not in the front. And folks, here's my answer. All right, next. This one you're going to see a lot. Let f of x be an antiderivative of sine cubed x. We do not know how to do this yet, okay? So don't freak out. We're going to do this with the calculator. If f of 1 equals 0, then f of 8 equals... Okay, f of x is the antiderivative of sine x cubed. So if I have sine x cubed, or sine cubed x, whatever, sine x cubed, and I integrate it, which is finding the antiderivative, I will get f of x. They're telling me that, and I need this information, it's really important. This f of 1 is 0. They want me to find f of 8. So here's the thing. They're telling me that if I plug in x equals 1, I get 0. And if I plug in x equals 8, I need to figure that out. So, according to the fundamental theorem of calculus, when I integrate this, I will get f, right? Because that's what I should get when I integrate this. F of whatever my lower limit is, so a, and then minus, or I said that backwards. OMG. What is wrong with me today? Oh boy. Let me just fill that out. There we go. So f of b, my upper limit, minus f of a, my lower limit. That is what the fundamental theorem of calculus tells me. If I am to integrate this function whose antiderivative is f of x, then it would equal f of b minus f of a. Now, your calculator has the power to tell you what the derivative of, or the integral of sine cubed, or sine x cubed is, but you need limits. So, since they gave us f of 1 equals 0, and we're looking for f of 8, those are perfect candidates to use as your limits, and that's the idea. Okay, this is going to be your lower limit, and this will be your upper limit. So, in the calculator, we're going to pop this in. 1, 8, sine x cubed. We're going to figure that out real quick. Okay, so math, any day now, number 9. All right, from 1 to, see, it keeps doing that. It keeps pressing more. I'm just going to type it in. Okay, I just typed it in. And the integral from 1 to 8 of sine x and then cubed is 0.6321. Okay, I'm just going to move that over. All right, so my answer is 0.632199, and that's enough for all intents and purposes here. Okay, so this is what my integral equals. Now, according to what I said, right, this here is how I would get my answer, which is this. Okay, so f of 1, or sorry, 8, I keep doing that, minus f of 1 equals 0.632199. According to this, f of 1 is 0, so f of 8 equals 0.632, and for AP, all you need are 3 decimal places. Now this time around, it so happened that this right here was 0. So that's why f of 8 is just 0.63219. But sometimes it'll be something else. If it was 3, you would have done, add 3 to both sides, and then it would have been 3.632, like that. Okay, this problem is like the initial conditions problem, only that it's worded differently. Let f be a function such that f double prime of x equals 6x plus 12. Find f of x if the graph of f is tangent to the line 4x minus y equals 5 at the point 0, negative 5. Being tangent to this line right here means that f of x is has the same slope as 4x minus 1 equals 5. So first of all, this is no friendly. So let me move this around. So let's see. I'm going to add the y to both sides and then subtract the 5. So here we go. This I know. Y equals mx plus b. So the slope is 4. So that means my slope at 0, -5 is 4. So that means f prime of x, which is my slope, right? The derivative is the slope, is equal to 4. But more specifically, f prime of x at, or when x is 0, is 4. So here's my first initial condition that I just found. Okay, so I'm going to take my f double prime, I'm going to integrate it. And when I do, that will get me my first derivative. Right? Let me move this over. Okay. So, the integral of 6x plus 12 dx. So it becomes x now is squared, and divide by my new exponent, which is 2, and 6 divided by 2 is 3, plus 12x plus c. So this, ladies and gents, is f prime of x. Now, according to my initial condition, right here, when I plug in 0, I get 4. So 0 plus 0 plus c equals 4. So c equals 4. That's totally a c. So that means that f prime of x is actually 3x squared plus 12x plus 4. Alright, I need to find f of x. So I'm going to integrate this. So integrate this, and I'll get f of x. Alright, so let's see. Add an exponent, divide by it, so 3 divided by 3 is 1. X is now squared, divide by the 2, so 12 divided by 2 is 6. And then plus 4x plus c. Now, if you go back to the information they gave us, I only had this green box here is the only thing I figured out. But they did tell us something else. Right here. This belongs to f of x. What this is saying is when I plug in a 0 to my function, it equals -5. So here's my other initial condition. Okay, 0, -5. When I plug in 0, I get -5. So I'm going to use that down here. When I plug in 0, I get -5. So c is -5. So f of x equals x cubed plus 6x squared plus 4x minus 5. And there's my answer. Okay, homework. Continue working on the Chapter 5 review. There's a quiz in next class and a quiz the following class, and then the test after that.